Imagine a metal so soft that if you drop a solid piece of it into the palm of your hand, your own body heat melts it into a silvery puddle. Gallium's industrial utility is found in its compounded forms, specifically gallium arsenide and gallium nitride. These compounds handle the high-frequency signals and massive electrical loads that standard silicon cannot, making them essential for advanced radar networks and 5G cell towers. Despite the importance of these compounds to both military and commercial hardware, the United States relies entirely on foreign imports for the raw material. Domestic production of primary, unrefined gallium in the U.S. ceased in 1987. Today, China controls 98% of the global supply. Beijing has begun using that leverage. Following a period of strict export licensing in 2023, China implemented a total ban on all gallium exports to the United States in December 2024. A metal that melts at room temperature has become a geopolitical tool used to target the foundation of modern semiconductor manufacturing. Building a new domestic supply is complicated by a geological reality. Gallium is not a primary ore. It is never mined for itself. Most gallium is recovered as a microscopic byproduct of processing bauxite, the reddish-brown rock used to produce aluminum. A smaller portion is pulled from zinc waste. The concentrations are incredibly thin. For every million parts of raw bauxite extracted from the earth, only about 50 parts are gallium. This creates a massive industrial requirement. Harvesting gallium at scale requires a nation to first operate massive alumina refining facilities. China's monopoly grew out of industrial scale. As the world's leading refiner of aluminum, they process the vast majority of the bauxite needed to capture gallium. Producing usable gallium involves a 4-stage process: bauxite mining, alumina refining, crude gallium extraction via the Bayer process, and high-purity refining. The final stage is the most demanding. Modern semiconductors require gallium purified to a standard of 99.9999%. Constructing a new refinery capable of this level of purity, even a facility with a modest 30 to 50-ton annual capacity, takes 4 to 5 years. In regions lacking existing aluminum infrastructure, that timeline extends to 7 or 8 years. The unyielding physical constraint of construction time remains the primary obstacle to semiconductor sovereignty. In response to China's export bans, the Pentagon initiated a domestic production push in 2026. This is a staggered transition rather than an immediate fix. The new domestic capacity is expected to arrive between late 2026 and 2030. A temporary reprieve arrived in November 2025, when Beijing suspended the total ban, though only until November 27, 2026. However, even during this suspension, the ban on U.S. military end users remains active. This leaves the United States facing a 4-year gap where its advanced domestic supply remains critically exposed. Beijing has temporarily loosened the tap for commercial users, but they keep their hand on the valve. The ability to halt the American advanced semiconductor industry remains under their control.